I'm Tony Flanagan from Stryker 3D, and I'll be the moderator of this session. Our first speaker is Triona from Stryker.
Thanks, Tony. Can everybody hear me? Okay, good. Okay. So I'm here from Stryker to talk mostly about additive manufacturing, but I'm going to start with a little explanation about Stryker and what we're about. So this is our mission. Together with our customers, we're driven to make healthcare better. And we do that through the set of values that's up here. So what we do what's right, we do what we say, and we go with talent and deliver performance. I've been with Stryker over 16 years, based in Cork all that time, and I can say for sure this is true. This is what we do. So that's a picture there of Homer Stryker, and 75 years ago he was working as a surgeon, and he didn't have the tools he needed. Now he was working as a surgeon, but actually he had started life as a mechanical engineer. Then he went off and fought in the war, and when he came back trained as a medic. And he found that there just weren't enough solutions there to provide better healthcare, and he started to invent himself. And 75 years on, there's over 25,000 employees globally. There's R&D and manufacturing in over 30 different sites. In fact, it's at 38 at the moment, so it's increasing all the time. We're the 9th biggest medical device company, and over 9.9 billion in sales in 2015. And we have a global mindset. So Stryker, the green on this slide here is where Stryker products are sold all over the world. So you can see it's pretty broad. There's quite a hub here in Ireland, because Stryker has a very strong presence there, and I'll get to that. But first, I'll just go through the different products that Stryker manufactures and supplies. So Stryker Orthopedics is in Ireland since 1998. Started building in 1997, and so the first two up there, there's a pointer here. The first two here, hips and knees, are manufactured in Munster. So too are the med-surg, the different tools and surgical parts. They're manufactured in Carrickfinn and County Cork, and we've neurovascular products that are manufactured in Cork as well, Model Farm Road. As well as that, Stryker has recently moved into robotic surgery, so with Mako, and essentially there's a very broad depth to what Stryker does, so it's not just orthopedics. And Stryker in Ireland, so I mentioned there that Stryker started looking in Ireland in 1997 for somewhere to set up manufacturing. They wanted to put two different divisions into Ireland, the instruments division, so med-surg, and also the orthopedics division. So they built two factories back then in Carrickfinn, they're side by side. And around the same time they acquired Homedica from Pfizer. So that's also a facility based in Maheen and Limerick, where we manufacture knees. And more recently then, Stryker started manufacturing coils for brain hemorrhage on Model Farm Road in Cork. So that's a business they acquired from Boston Scientific. More recently still, this is a dedicated research and innovation centre which is opened in Cork just there in January. The team moved into it in December. And this here is the 5th manufacturing site, which will also be located in Cork, that's currently under construction. So Stryker is huge in Ireland, with over 2,200 employees in Munster. 25% of global sales in 2014 were manufactured in Munster. And now, I'll get to the interesting bit. So Stryker is all about innovation, really. And why I'm here today, why me in particular, is because I've been managing a project getting additive manufacturing as a for mass production of titanium medical implants. A bit of background first. So there's a lot of talk about additive manufacturing, a lot of hype in fact, and on the internet if you Google it you'll just see so much information, and a lot of that is hype. But in fact we started looking at additive manufacturing back in the late 90s. And why did we? So here is a very unhappy hip. So what's our target product in orthopedics is for total hip arthroplasty or total knee arthroplasty. So if you've got a wear cartilage and bone on bone, then your joint looks something like this. And here's a typical replacement that we manufacture. Similarly for the knee, very unhappy looking knee there, here in particular, you can see it in the X-ray, where you've bone on bone and a lot of pain, and this is the kind of construct, modular, that's implanted to replace the damaged knee. And when these devices were first manufactured and implanted, a cement was used to hold them in place. Whereas, and there's a lot of bone loss with that, you've got to remove a lot of bone to fit the implant in and to make sure that it's fixed. And what Stryker has championed is actually press fit. So you're only taking away the amount of bone you have to take away, because bone likes to grow. And the bone will grow onto, if we provide the right conditions, the bone will grow onto these implants. So this is one of our first generation press fit implants, and that's the kind of surface that we have. So what we're trying to do here is increase the surface area so the bone can grow on. But ideally really what we want is for the bone to grow into the implant, and for that we want to make foam. So over the years we've developed a number of different ways of providing this 3D interconnecting porosity or foam. That's why we started looking at 3D printing or additive manufacturing. So back in the late 1990s, University of Liverpool were looking at 3D printing, additive manufacturing in metal. They were trying to get more dense structures, and in fact we wanted more porous structures, and we went to work together. And patents started to flow. And by 2005, our manufacturing team, ourselves in Cork, started to get involved. And by 2007, we had prototype equipment on site in Cork. There's a long distance there between 2007 and 2011. It took 5 years for us to actually get the different companies supplying this equipment to realise what it was we really needed. We used the prototype equipment and to develop the specification, and by 2011 we had the first production capable equipment on site. And 2013 we got FDA 510K clearance for the first implants. And at this stage in 2016 we were over 15,000 implantations of products that were made by additive manufacturing. And they've all been manufactured in Ireland, which is nice to add on there. So why additive as opposed to conventional? Well, what is it? So if you're familiar with graphic prototyping or the 3D printing that's so hyped up at the moment, whatever you want to make, so I want to make that, I model that in CAD, slice it, and then feed that slice file into a machine, and it will build up the product slice by slice, the slices that I created. And that gives us great design freedom, a much reduced development time, and we can combine porous and solid structures in one design in a way we never can or never could with conventional means. What's open here, and it's not what we're doing it, but what is also very possible here is that you could go into the custom side. So no individual is the same, so you could actually scan a patient and print them up something in custom. And some of that's been done, but not in any kind of a large scale. As well as that then, the method for manufacturing is near net, with very little waste, and in fact any of the unmelted powder that we have can be reused. So it's also very green, so it ticks a lot of boxes. This chain wheel was built using additive manufacturing on our machines. So I mean it's not a product, but it just shows you some of the capability of, and some of what's possible now that wasn't possible before with manufacturing. So just a little bit about the process itself. So every element of the foam and the solid is modeled up on CAD. So as I mentioned, that gives us unique design capabilities. So if you had a choice, what would you really implant into a human? Well, you'd implant bone. I'm sure you'd get exact. So what we've actually modeled up here is something that looks or is exactly like cancellous bone. And surprise, bone loves it and loves to grow into it. So that SEM image there, that shows you what it is that we're presenting now to bone on the outside of our implants. Okay. And this is a video that it's an animation of the process itself. So that's the size of the build plate, that's 250 by 250 about. So you lay down a layer of powder and then you selectively melt whatever it is you're trying to create. So they're just some supports, schematically obviously. And here we go, melting again, another layer of powder, another layer of powder, and then back it goes, and then it just raises up. And obviously in real life these are actually in a bed of powder. This is the most recent product that we've launched. It's a spinal implant, and it's blowing the surgeons away because there is no other way of making that implant right now from metal. They're made from a polymer, and really they don't work very well. So I don't know about you, but if somebody's giving, at my spine with surgery, I want to know that what's going in there is the best thing possible. So here's a picture of the various implants that we've launched so far, and in fact in stand 60, just behind us here, you can see these and take them and hold them. So this product here, this is a tibial base plate that's manufactured entirely from additive manufacturing. And some of the features, there's a little window there of foam on the keel, and that's huge for the surgeons because it means they're not worried about extraction afterwards. And as well as that then, so while it's really good not to use the cement and to have this press fit technology, the initial fixation is something that is a big concern. So something we couldn't do before, see these little pegs here, we put these into the product and it really helps with the initial fixation. And there's different features like that we could model in that we can't do in any other way. Okay, this is kind of go backwards. Okay, but it's fine. Move on to the products here. So yeah, so that's that same image here with the implantable products. Triathlon is really good knee. It's got over 10 years clinical history. It's all manufactured in Limerick, except for this base plate here, which is now manufactured using additive manufacturing in Cork. Previously, that was manufactured from Cobalt Chrome, and that's still available. And just what I have here is just some more detail as to what it is that this technology gives you that you can't do by conventional means. So, as I mentioned, you model up in CAD, you slice the file, and then use your model, and then you build it up. It's the build plate, and they're the tibial base plates they're building up. So the pegs that I mentioned, the tibial base plate, if you were to try and cast something like that and test out different peg shapes, like what's the best shape? What is it that when the surgeon implants the implant, what gives him the best initial fixation? What shape gives him the best initial fixation? So we tested a lot more than this, but here's a representation of what we tested. And rather than just doing modelling or something like that, we could actually build them. We could design them, make them, and test each one and say, well, what is actually the best way of doing this? And in fact, the cruciform that we have there, which is ultimately on the product, that is the strongest by a long way, and that's what we have in the product. Similarly, if you look at the patella, so this is your kneecap. Modelling up in CAD here, these little pegs, these three little pegs again give the fixation that's required. And if we were to make this through a coating like we used to before, then those pegs would have to be entirely from the coating, and therefore not particularly strong or perhaps not strong enough. But in this case, we could just put a solid core up the middle and make them strong enough. We could also design the bony ingrowth surface here, just like this, like the SEM I showed you previously. But then in the back, because we're moulding to polymer, to give us our bearing surface, we could do a completely different foam for the interdigitation of the poly. So if there's any design engineers here, this just opens up a whole world. The constraints that you had before are not there. Okay, so there we go again. That was the very first surgery, so it's been all plain sailing since then. So just to conclude, to summarise, so we have a validated state-of-the-art production hardware and software, and that's key, and that's what took all the years from 2001 up to 2013, was to actually get this to a stage where we could use it for mass production. There's a lot of companies out there selling equipment that you can plug in and you can produce something straight away, but actually to get through make sure that the products that you're making are actually good and that you can stand over them, and also that you can still make them in 10 or 20 years time, which is another, when we build a clinical history on a product, and we need to be able to ensure that we can still make that product. We have complexity at no extra cost, and again, a lot of people say it's free. There's nothing that's free, but you can add a whole lot of complexity to your design, and it doesn't cost anything extra. The kind of design features that we have on here, if you were to try to forge them or cast them, the cost of that is enormous, whereas for this, it's just a simple case of changing your CAD model. We can tailor the structures physically and mechanically. No, we can put strength where it's needed. Reduction in product development time. You know, we've had other ways of doing this, but actually every time we wanted to make a new product, it was 3, 4, 5 year lead time to develop that. And there we go. I think that
Triona, thanks very much. That was amazing. Of course, Stryker is an acknowledged innovator and industry leader in the field of additive manufacturing. Before we throw it open to the floor, can I ask a question on that? Obviously, loads of information at the moment about the investment, the huge investment Stryker is making in additive manufacturing. What does that mean for Ireland? Any good news coming our way?
So, as I mentioned, the development took place in Ireland. So the advanced operations team that was doing this work was led by me, based in Cork. The products are all being made in Ireland, so I'm not at liberty to say, but yes, you can expect some.